Okay, in this lecture we're going to talk about exponents and what's going to lead to what we call exponential functions. Now, you remember that we had exponent rules. Right, for example, when we had this, we actually added the exponents. Okay, and we had a whole bunch of these. If we had divide, then we'd subtract, and of course if we multiplied the exponents, then this is really the result of doing this. Now, what we're interested in here is what happens if we have a rational exponent. So, for example, you remember that we talked about this. If I have a to the m divided by n, alright, well this is the nth root of a to the m, okay, which of course is the same as the nth root of a all to the m, okay. So, and this is the rational exponents rule, and we certainly know how to do that. For example, if we had 64 to the negative a half, alright, then this would be equal to 1 over 64 to the half, which of course is the square root of 64, which is 1 on 8. Okay. Right, now the question begs itself, of course, well, what if we don't have something that's easy to work with? I mean, we can also say, well, suppose I want to find 3 raised to the power of square root of 5, for example. Okay, and that's a bit more difficult to deal with. So we want to talk about this kind of issue and be able to actually find what is the answer to that kind of question. Now, when this was devised, of course, we didn't have calculators, so we just couldn't plug it into a calculator. Alright, so we do have some properties here, and I'm going to put the properties down here and then do some examples. Okay, so let's talk about properties of exponents here that add on to what we already know about exponents. Right, and the first one is this. Let's suppose we have a real number, okay, alright, and I don't have it equal to 1, and it's a real number. Okay, then we have the following properties. A to the power of x, okay, notice that we're talking about x here is varying now, is a unique, that means there's only one of them, okay, unique real number. Okay, for all real numbers x. So in other words, we can vary x here across all real numbers, and for each x we're just going to get the value of a raised to that real number as a unique, or there is only one answer to that particular calculation. Right, part B. If I have a number raised to the power of b, and this is equal to the same number raised to the power of c, for example, right, then we have b is equal to c. Now this is a two-way street, so we can always write this as a to the power of b equals a to the power of c if and only if b equals c. So it's a two-way result. Alright, so next, part C. Right, if in fact a is greater than 1 now, so here we started with a is greater than 0, but let's suppose we made it more stringent, that a is now greater than 1, and if I have m is less than n, then our result is that a to the power of m, okay, notice m is smaller here, is going to be less than a to the power of n. Okay, so as long as a is greater than 1, then a smaller exponent produces a smaller number when raised to that power than the number that's raised to a higher power. However, if I have a is between 1 and 0 now, notice it's still greater than 0, but now it's between 1 and 0, like it's a half or something like that, and we still have that m is less than n, then we have that a to the m will in fact be greater than a to the n. Right, so let's look at some examples of this. Let's suppose that we have, let's suppose that f of x is going to be equal to 4 to the x. Now, let's suppose we want to find part A. Let's suppose we want to find f to the negative 3. Then this would be 4 to the negative 3, which of course is 1 over 4 to the 3. Now 4 to the 3 is 4 times 4 is 16, by 4 is 64, so I'd end up with 1 on 64. Let's do part B. Let's suppose I want to find f of 3. Then this would be 4 to the 3, which of course is clearly 64. If I want to look at, let's suppose I want to do f of 2/3. Alright, well this will be 4 to the 2/3. Right, now if we find 4 to the 2/3, then this will in fact be 4 squared to the 1/3, okay, which of course is 16 to the 1/3. Now of course this is going to be 2 cubed, which is 8, times 2 to the 3rd, which of course is going to be 2 to the power of 3 raised to the power of 3rd will of course be 2, and then cube root of 2. Okay. Alright, so we end up with that. And finally, what if we have something that's not easily manipulated like this? Let's suppose I want f of, say, 3.25. Then we're talking about 4 to the 3.25. Right, now to do that we're going to have to use a calculator. Okay, and notice we have a y to the x button here, so we're going to put in 4, okay, raise it to the power of 3.25 equals, and we end up with this being 90.51, say, to 2 decimal places. Right, and that's how we do that. All right, now the next thing I want to talk about is, well, this thing here really is representing a function, and it's actually an example of a exponential function. So whenever I have a function of some fixed number, let's call it a, raised to a power of x, where this is the variable, this is actually called the base, then this produces an exponential function. Okay? Alright, in this case here, we have a couple of conditions. So if, of course, a is greater than 0, we're not going to look at bases that are negative. Alright, and a is not equal to 1, because if I had a base of 1, everything to the power of 1 is 1, so it's a very boring relationship. And then f of x equals a to the x, right, defines an exponential function. Okay. Right, so examples of this would be, of course, f of x equals 2 to the x. Right, f of x equals half to the x, which of course is really just simply 2 to the negative x. Okay, we could have f of x equals 10 to the x. Okay, we also have one that's actually f of x is equal to e to the x, which is going to be an interesting one, where e is what's called Euler's number. And we're going to talk about that because it has some very important applications. Well, what does a graph of this actually look like? And we want to actually do a picture of this So we're going to do f of x is equal to 2 to the power of x. So we're going to make up a table of values, x, and this will be 2 to the x. So I'm going to draw, say, some negative ones. And let's have a look and see what we get. Well, what is 2 to the negative x? Well, it's 2 to the, x, and 2 to the negative 2 will in fact be, okay, so if we look at 2 to the negative 2, so I'm going to put my ordered pairs here too. So this will be 2 to the negative 2. So that'll be 1 over 2 squared, which is a quarter, so it's negative 2 a quarter. Here I'm going to have 2 to the negative 1, so that's 1 over 2, which of course will be negative 1/2. Put 2 to the 0, now 2 to the 0 is always 1. Anything raised to the power of 0 is 1, so this will in fact be 0, 1. When I put 1 in here, of course, this is clearly going to be 2. This one will be 2 squared, which of course will be 4. This will be 2 cubed, so that'll be 8. Right, so we've got some values to do here. So we have negative 2 a quarter. Right, we have negative 1/2. We have 0, 1, 1, 2, 2, 4, and 3, 8. So clearly our function comes down here like this. If I can draw it carefully. Swings around and just gets smaller and smaller as x gets larger and larger in the negative direction. Right, so that's our function f of x equals 2 to the x. Okay. Now, is this a one-to-one function? Well, yes, it is, because if I put a horizontal line through there, all right, so yes, all right, this is one-to-one. So there will be an inverse, and that's going to be important to be able to find. Now, what if I had f of x was equal to 1/2 to the x? Okay, which is really this one here. How would this actually change? Well, you should have some idea based on the fact that the negative now is being applied to the x part first. Okay, all right, and so let's do the same points. We've now got 2 to the negative x. Okay, so now this becomes 2 to the negative of negative 2, which is positive 2, so that's now 4. So this will be negative 2, 4. If I put negative 1 here, this becomes 2 to the 1 now, so it'll be negative 1, 2. Alright, 2 to the 0, of course, is still 1. Now if I have 1, this will be 2 to the negative 1, so that'll be 1/2. 2 to the negative 2 now will be 2 1/4. And 2 to the negative 3 will be 2 and 1/8. Alright, so what we have here is negative 2, 4, and as you suspected, really this is just going to be a reflection in the y-axis, okay, which is what we determined once before. When we will have all functions and we apply a negative to the function part, and it reflects in the y-axis here. So now, so we look at this one here and we end up with 0, 1 again. We look at negative 1, 2. Okay, and then we come down here to 1/2, 1/4, and 1/8, of course. So if I did negative 3, it would be 1/8, so that would be up here. So let's see if I can draw this one. There it is there. So this will be y equals 2 to the negative x, which of course is the same as a half to the x. Alright, so there's a brief introduction to exponential functions, and also the how do we evaluate them, how to do a graph. We'll next talk about their characteristics.